Hey guys, welcome to a video walkthrough of the AFAM Unit 4 review test. We're going to be going through this. I'm hoping to get through it in maybe 3 videos. We'll see what happens. So in this first problem, it gives you a bunch of information. If f is 1-to-1 function and f of 5 is 3, f of negative 1 is 8, f of 3 is 9, find these two things. And it's important to note that it's giving you 3 different pieces of information in the question itself. So if you skipped reading this, then you're going to have no idea what's going on, and rightfully so. You have to realize that this information is going with these questions. So make sure you read the instructions. And here we go. With these 3 pieces of information, you're supposed to find the inverse of 8. And if you recall, this little symbol means inverse, and inverse means opposite. So usually in this notation, what it says, like if I just kind of cover this up, if you were given something that said f of 8, it says if x is 8, then what is the y value? But this is going to be the opposite. It's saying if 8 is the y value, then what was the x value? And if you look over here, the only time you see is an 8 is right here, where if x is negative 1, then y is 8. And it's asking you just to go backwards. It's saying if the y value is 8, then the x value would have had to been negative 1. Over here with this one, it says 9. So if the y value is 9, the x value was 3. So they are easy questions as long as you understand what it's trying to ask for. And once again, it's just you're going backwards. Whatever it's matched with is the answer. For the next question, it says, write the inverse of the following relations. State the domain and range for both the original and the inverse. So the original here is just a bunch of ordered pairs. Just recall, ordered pairs are a bunch of x and y's being paired to each other. And inverse means opposite, which means to find the inverse, you're just going to switch the 2 numbers. Instead of x to y, you're going to do y into x. So it looks like the domain, I guess we'll start with that then. The domain is the x values and range is the y values. So if you go through this, all of the x values are listed first. So those things I just underlined are the domain. So I'm just going to write them out. 5, negative 3, 2, negative 7, and 1. That's going to be the domain. And the range are the y values, which are those ones that I'm circling. So I'll write them out. 6, 7, 5, negative 1, and 2. Boom, done. Inverse relation. So as I said, what we're going to do is just switch those 2 numbers. Instead of 5, 6, 6, 5. Instead of negative 3, 7, 7, negative 3. You're not changing the numbers, you're just switching their location. So negative 1, negative 7, and 2, 1. So just flippy floppy, the x and the y. Note that when you do the domain now, everything that was a y value is now an x value, and everything that was an x is now a y. So if you notice, the domain is now what the inverse used to be for the range. So instead of like going through this and doing the exact same thing, you can just know that the domain of this one is going to be the range of that one. So I'm just going to copy it. 5, negative 3, 2, negative 7, 1. And this one is going to go over here. 6, 7, 5, negative 1, and 2. And you can just quickly see that that's going to be the case. The domain, 6, 7, 5, negative 1, and 2. It all checks out. It's just the domain is going to be the range of the other one and vice versa. So there you go. For the next problem, use the appropriate test to circle if it's 1-to-1 or not. All you have to do is check to see if it passes the vertical and horizontal line tests. If you forgot what that is, it means you should be able to draw a vertical line and only go through it once. You should be able to draw a horizontal line and it only goes through it once. In this case, it does pass the vertical line test. no matter where you draw a vertical line, it's only ever going to go through the graph once. But it does not pass the horizontal line test. Like here, it would only hit once. Here, it would only hit once. But if you draw it here, it hit 3 times. So it does not pass the horizontal line test. So it's going to be no. Over here, it does pass a vertical line test. It also passes a horizontal line test. So it would be 1-to-1. And moving on to the next page. Explain underneath the graph why the functions are 1-to-1 or not. Well, I basically said it already. This one, does it pass the vertical? Yes. Does it pass the horizontal? Not so much. It would hit twice right there. So it fails the horizontal line test. So the answer is going to be no. Boom, just like that. Fails the horizontal line test. Mathematically, the reasoning would be because there is a y value with 2 x values. That's the math way. In a 1-to-1 function, each x has exactly 1 y value, and each y value has exactly 1 x value. But as you can see here, there is a y value that has 2 different x values, so it would not be. It fails the horizontal line test, and would not be. This looks like it passes vertical. It looks like it also passes horizontal line. So yes, passes. I'm going to get lazy. Vertical line test and horizontal line test. There we go. Boom. Done. So hopefully pretty easy so far. In number 5, draw the inverse relation. The first thing you should do is any ordered pairs they give you right off the bat, definitely use them. They're going to be very helpful. What you do is, once again, inverse means opposite. And just like we did on the previous page, if you ever have x's and y's, you can switch them. So instead of -2, 0, you can have 0, -2. Instead of 0, 3, you can have 3, 0. So if you draw, let's see, 1, 2, 3, 1, 2, 1. I'm just trying to get a sense of scale for drawing more tick marks. Okay. So if you do 0, -2, that would be right here. And if you do 3, 0, that'd be right here, like so. This question is actually harder than the next one. The reason for that is because, like, even with these points, you can't necessarily know what it's going to look like. Like, if you make this big line here, it's going to be wrong, because this is a curve, so this is going to have to be a similar curve. What you're supposed to do is kind of turn the graph this way and draw a main diagonal like this. And the graph that you have right here is supposed to reflect across that line. So like this part over here would reflect over like that, like a reflection of a mirror. This would start going towards that. Boom. This middle part's going to be kind of weirder, especially since as much as I tried to scale it correctly, it looks like it didn't. This should have been reflected over there. My bad. But anyways, you know, on a test, I'm not going to be super particular as long as things look decently okay. So like if you just kind of connect those, I'd be like, okay, fine. But for this part, since this is getting closer to the line and then going away, this will also get closer to the line and then go away, like so. And that's what the graph is going to look like. If this goes towards and away, this will go towards and away. And it's going to look something like that. Yeah, it doesn't look pretty at all. My bad. But, you know, on a test and quiz, I'd still give you credit for that. You know it's supposed to look like a reflection. And I won't blame you for being a bad drawer. So there you go. That is number 5A. Good enough. B is easier because it is not a crazy straight shape, as well as you are given a lot of ordered pairs. Boom, boom, boom. All of these things. Technically, you could also see one there and there. This point is completely useless. It's put in there to throw you off. And there you go. We'll do the same thing as before. I'm just going to write down all these ordered pairs. -2, 5. That pen is not working well. -1, 0. 0, -3. 1, -4. 2, -3. I'm probably going off the page for you guys, aren't I? 3, 0. And 4, 5. Now, do I need to write down all these ordered pairs? No. Did I? Yeah. The more points you have, the more obvious it's going to be what the answer is. So -2, 5 will be 5, -2. -1, 0. 0, -1. 3, 0. Once again, all I'm doing is switching the two numbers. All right, switch the two numbers. -3, 2. 0, 3. And finally, 5, 4. And I'm going to graph all of these points. So 5, -2 seems to be off the graph, but it's going to be somewhere like that. 0, -1. -3, 0. -4, 1. -3, 2. 0, 3. And 5, 4. Something like that. Okay, so those are a bunch of points. And like, even though I've graphed these points, you might have difficulty still graphing it. Another thing you can look at is that if you look at this original thing, if you can find any special points, then whatever makes a point special, that exact same specialness is going to be happening at the inverse. So like, for instance, what I'm kind of alluding to is this point right here. This is called a vertex. It's also a turning point. So if you see that at 1, -4, it's turning at 1, -4, that means at -4, 1, it is also going to be turning. So here at -4, 1, it is also going to be turning. So what was here will be turning to be over there. And that'll now be the inverse. And there we go. That's the first 2 pages. Maybe I can get through this in 2 videos. Let's hope. Okay, so that's part 1 done. See you in a minute.